Hello students, in this class we will learn how we can solve logarithmic problems. That means in the problems how we can apply logarithmic formulas, that means sum property. Solution. Log of 8 base 5 into log of 24 base 8 into log of x base 24 equals to log of 512 base 8 imply log of 24 base 5 into log of x base 24 is equals to log of 512 base 8. These two becomes this, that is log of 8 base 5 into log of 24 base 8 becomes log of 24 base 5 by the formula log of a base c into log of c base b is equals to log of a base c into log of b base a becomes log of b base c. Already we know this formula. Log of a base c into log of b base a is equals to log of b base c. So by this formula we have log of 8 base 5 into log of 24 base 8 is equals to log of 24 base 5. These two can be written as log of x base 5 is equals to log of 512 means 8 cube base 8. So these two can be written as log of x base 5 by following this formula. Now log of x base 5 becomes equals to log of 3 into log of 8 base 8. Since we have log of x to the power n base a is equals to n into log of x base a. So this will give log of x base 5 is equals to 3 into 1. Since log of a base a is equals to 1, by following this relation we can write log of 8 base 8 is equals to 1. So this becomes log of x base 5 is equals to 3. This will give x equals to 5 cube. Since since x equals to log of m base a imply m equals to a to the power x by the, or we can say from the definition of logarithm. Okay, if we follow the definition of logarithm, then we have x equals to log of m base a is equals to m equals to, this implies m equals to a to the power x. So by following this relation we have log of x base 5 equals to 3 imply x equals to 5 cube. So this will give x equals to 125. So this is the value of x. So this is the way by which we can find the value of x from this given equation. Okay. Now we will solve problem number 2. In problem number 2, we have to express m in terms of n from this given equation. Okay. So here we have half into log of m base 3 plus 3 into log of n base 3 is equals to 1. From this relation, we have to express m in terms of n. So let us study how we can express m in terms of n. Therefore, half into log of m base 3 plus 3 into log of n base 3 equals to 1 imply log of m to the power half base 3 plus log of n cube base 3 is equals to 1 by following the relation n into log of x base a is equals to log of x to the power n base a. So by following this relation, we can write half into log of m base 3 as log of m to the power half base 3, where n is equals to half, and from 3 into log of n base 3 as log of n cube base 3. Okay. Now this is like this 2 is like log of p base a plus log of q base a equals to log of p into q base a. Now this 2 is like log of p base a plus log of q base a. Already we know when the bases are equal, then at the time of addition we can write this thing as log of p into q base a. So by following this relation, we can write log of m to the power half into n cube base 3 is equals to 1. So this thing can be written as, since x equals to log of m base a, imply m equals to a to the power x by following the definition of logarithm. So from this we can write m to the power half into n cube is equals to 3 to the power 1. Here this is like m, this is like a, and 1 is like x. Okay. So now we have to express m in terms of n. That is why we have to remove this half. That means the power of m. So to remove this half, we have to square on both sides. So m to the power half into n cube whole square will give 3 square, squaring both sides. So this will give m to the power half whole square into n cube whole square is equals to 9. Since ab whole to the power m is equals to a to the power m into b to the power m by following the exponent or indices formula. So from m to the power half whole square will give m into n to the power 6 is equals to 9. From this we can write m equals to 9 by n to the power 6. So this is the way by which we can represent m in terms of n. So this is the required expression of m in terms of n. Okay, so this is the way by which we can represent m in terms of n. Now we will solve problem 3. In problem number 3, here we have an equation, and from this equation we have to find the value of x. Okay, so let us study how we can find x from this equation, or you can say logarithmic equation. Since log of 5 root over of x plus 5 plus root x equals to 0. So here we have a problem. The problem is that log of there is a first log whose base is 7, and this is the result. Okay, so this is like m. Mane this problem is looking like log of m base a, where m equals to log of root over of x plus 5 plus root x base 5. Okay, so this problem is looking like log of m base a, where m equals to this, that is log of root over of x plus 5 plus root x base 5. This is like m, and a is equals to 7. Okay, so this problem is looking like this. So by which way we can find the value of x? So from this we can write log of root over of x plus 5 plus root x base 5 is equals to 7 to the power 0. Since log of m base a is equals to x, imply m equals to a to the power x by following the definition of logarithm. So by following this relation or definition of logarithm, we can write this is equals to 7 to the power 0. So this imply log of root over of x plus 5 plus root x is base 5 is equals to 7 to the power 0 means 1, because we know something to the power 0 is 1, that is why 7 to the power 0 becomes 1. Again we can use this definition of logarithm. It is also looking like log of m base a equals to x. So from this we can write root over of x plus 5 plus root x is equals to 5 to the power 1. Here this is like m, and 5 is like a, and 1 is like x. So this will give root over of x plus 5 plus root x, no sorry, root over of x plus 5 is equals to 5 minus root x. So from this, if we want to find x, then we have to remove these square roots. That is why we have to square on both sides. So squaring both sides, we get root over of x plus 5 whole square plus 5 minus root x whole square. This will give x plus 5 is equals to, it is like a minus b whole square. So a square plus b square minus 2 into a into b. So this will give x plus 20, x plus 5 is equals to 25 plus x minus 10 root x. We can cancel this x from both sides. So we have 10 root x is equals to 25 minus 5. This will give root x is equals to 20 by 10. So this will give root x equals to 2. Now squaring both sides, we get root x whole square equals to 2 square. So this will give x equals to 4. So this is the way by which we can find a logarithmic equation. That means when there is one unknown like x, then how we can find its value. Okay. So here, since here we get only one value of x and it is positive, then there is then we can say this value of x will satisfy this equation. But if there are two different values of x and if one of them is negative, then after finding those values of x, we have to put those values in this equation. If for those different values of x, this thing, that is root over of x plus 5 plus root x, is always positive, then we can say those two different values of x will be the value of will be the solution of this equation. Otherwise they will not be the solution of this equation. Okay. So already we learned how we can solve these kind of problems. All these three kinds of problem. Okay. Now in problem number 4, we have a proof, that is we have to prove the value of this is equals to 1. Okay. So when we study this problem, then we will see in all of these terms the base are same, that is 10 is the base. Okay. So to make this a formula, we have to express this in kind of way: log of m base a plus log of n base a plus log of p base a plus continuing is equals to log of m base m into n into p into continuing base a. Okay. So since the bases of individual terms are same, so then we have to convert this in this form because we already study this formula. Okay. So since log of 2 base 10 plus 16 log of 16 by 15 base 10 plus 12 into log of 25 by 24 base 10 plus 7 into log of 81 base 80 in the LHS. So we can represent this as LHS. So LHS is equals to this is log of 2 base 10 plus 16 into log of 16 by 15 base 10 plus oh, sorry, there is a mistake. The last term is 7 into log of 81 by 80 base 10. So this will remain same, that is log of 2 base 10, and this can be written as log of 16 by 15 whole to the power of 16 base 10. So this can be written as log of 16 by 15 whole to the power 16 base 10 by following this relation. Since n into log of x base a is equals to log of x to the power n base a. So by following this relation, we can write 16 into log of 16 by 15 base 10 as log of 16 by 15 whole to the power 16 base 10. This similarly we can write this as log of 24 by 25 by 24 whole to the power 12 base 10. This can be written as log of 81 by 80 whole to the power 7 base 10. Okay. So these terms can be represented by this by following this relation. Now these are like log of m base a plus log of n base a plus log of p base a plus log of q base a. That means these terms are looking like this form. So from this relation we can write 2 into 16 by 15 whole to the power 16 into 25 by 24 whole to the power 12 into 81 by 80 whole to the power 7 base 10. So these can be written as log of 2 into 2 to the power 4 by 3 into 5 whole to the power 16 into 5 square by 2 cube into 3 whole to the power 12 into 3 to the power 4 by 2 to the power 4 into 5 whole to the power 7 base 10. Okay. So, so this is the simplification or simplest form of these numbers. This will give log of 2 into 2 to the power 64 by 3 to the power 16 into 5 to the power 16 into 5 to the power 24 by 2 to the power 36 into 3 to the power 12. This will give 3 to the power 28 by 2 to the power 28 into 5 to the power 7 base 10. Since AB whole to the power m is equals to A to the power m into B to the power m, and A by B whole to the power m is equals to A to the power n by B to the power n. So first of all we have to represent the prime factors of these numbers. Like this way, we can represent 16 as 2 to the power 4, 15 as 3 into 5, 25 as 5 square, 24 as 2 cube into 3, that is 8 into 3, 81 as 3 to the power 4, and 80 as 2 to the power 4 into 5, that is 16 into 5 is equals to 80. Okay, then we can apply this indices or exponent relation here, and after applying this relation we have log of base 10, then 2 into, now we have to accumulate the same base numbers. Two to the power 36 into 2 to the power 28. Then 3 to the power 28 by 3 to the power 16 into 3 to the power 12, 5 to the power 24 by 5 to the power 16 into 5 to the power 7. Okay, and the base is 10. 2 to the power 1 plus 64 by 2 to the power 36 plus 28 into 3 to the power 28 by 3 to the power 16 plus 12 into 5 to the power 24 by 5 to the power 16 plus 7. Since a to the power m into b to the into a to the power n will give a to the power of m plus n. So by following this relation we can add this or multiply this. Okay, so nothing is here means 1 is here, that is why this becomes 2 to the power of 1 plus 64. This is 2 to the power of 36 plus 28. This will remain same, and this becomes 3 to the power 16 plus 12. This will remain same, and this becomes 5 to the power 16 plus 7. Okay, base 10, this becomes 2 to the power 65 by 2 to the power 64 into 3 to the power 28 by 3 to the power 28 into 5 to the power 24 by 5 to the power 23. So these two can cancel out, and now these and these two forms are looking like a to the power m by a to the power n is equals to a to the power of m minus n. That is, when in case of division, when the bases are equal, then we can write this as common base, that is a to the power of upper power minus lower power, that is m minus n. So by following this relation, we can write log of 2 to the power 65 minus 64 into 5 to the power of 24 minus 23 base 10. This will give log of 2 into 5 base 10. This will give log of 10 base 10. Log of 10 base 10 means 1, since log of a base a is equals to 1. So this becomes equal with the right hand side item. Thus we get our proof. Okay. So this is the way by which we can prove this is equals to 1. So to do this, we have to do this. First of all, we have to study the problem properly. And here, in all terms, the bases are same and the bases are 10. That is why we have to express this expression by this way. And after expressing all of these terms in this way, we can use this formula, that is log of m into n into p continuing base a. Okay. Then we have to express these individual numbers by the product form of their prime factors. Thus we get this as this. Then we use some exponent or indices formula, and after applying those formula, we get log of 10 base 10, which is equals to 1, and thus we get our RHS. Okay.